Hello, my name is Mike, and welcome to my build video for the Zlob Modular VnIcursal VCA module. Here is the package it comes in. This is not a sponsored video. I bought this kit with my own money. Let's go ahead and open it up. The background music to this video was made using the Zlob Modular VnIcursal VCA module as the primary VCA. Here is the faceplate. This is version 666.1. There are no instructions included with the kit. The instructions are on Zlob Modular's website. During this video, I'll be following along with the instructions on my phone. We're going to start off with the resistors. This kit uses resistor arrays, with each array taking the place of 3 separate resistors, so it cuts down on a lot of the components and the time it takes. This kit took me about 4 hours. The resistor arrays are helpfully labeled, and this is my first time using them, so I haven't used a multimeter to measure resistor arrays before. The individual resistors are also labeled, but I always like to confirm, so I'm going to bring out the multimeter here, and we're going to measure one resistor from each group. The instructions have a note saying you may want to solder the trimmers to the board first, but the order of the instructions starts with the resistor arrays, then the trimmers, so I decided to just follow that. Since I've never measured a resistor array before, I decided to try it out. I did 2 legs next to each other and got a reading. I discovered that the pairs of the legs match each other. If you measure 2 legs next to each other, you get a reading, but if you skip a leg, you don't. The 6-legged arrays do not have a specific orientation, but the one 7-legged array included in the kit does. I'll have to be careful when I get to that one. I was supposed to trim the array legs, but later on I discovered there's a note in the instructions saying they do not need to be trimmed. So, do not trim the array legs like I'm doing here. See me using a utility knife blade to stand up an array leg so that I can trim it. And here's the note where it says, it's not necessary to snip array legs after soldering. Oops. Now we move on to the 1K resistor arrays. When bending these pins to hold the arrays in place, I make sure that I'm not bending them towards anything that could potentially result in a solder bridge. Now I'm doing the 7-pin 100K resistor array, which does have a specific orientation. The end with this dot needs to go into this highlighted square printed on the PCB. I decide to trim off one particular leg because it's awfully close to where the power pins will be. Next, the instructions tell us to add the 6 100K trimmers on the other side of the PCB. I make sure I have all 6 trimmers and that they all have the same marking, 104. I secure one leg on each trimmer and then go back and solder the rest. On the question of whether to do the trimmers first or the arrays first, I only really notice a conflict in this area where there are 2 trimmer legs that are a bit close to the array. I don't want to accidentally melt the coating of the resistor array while soldering these legs, so I make sure that my iron approaches from the side away from the arrays. As for the question of whether to do the arrays first or the trimmers, I feel like if you do the trimmers first, then you'll end up with the PCB raised in a way that would make placing and soldering the arrays harder. Now we're doing the individual resistors. These resistors are standing up sideways. We're bending the resistors over like this so that they will stand on end on the PCB. It is important to be mindful not to hit the plastic of one of the trimmers with the soldering iron, because that will absolutely melt. Even just being close to it can melt it. Extra careful you don't accidentally trim one of the trimmer legs, as that would ruin the component and likely require a replacement. There are no labels on the board that say 47K. Instead, they're labeled L1 to L6. The online instructions have them all diagrammed out, so you can get a better idea of where they are on the board. Here I have a set of 10K resistors, but it looks like they go on the control board, so I'll set those aside until later. Now we're doing the ceramic capacitors. These are not polarized, they can be placed either way, but it's best practice to try to place them so that the value markings are visible so that you can read them in case you need to troubleshoot later. We're doing the polarized electrolytic capacitors. Orientation does matter with these. The longer leg should be in the hole marked positive with a plus sign. Now we're placing the IC sockets. It is important to make sure that the notch on the socket is facing the same direction as the notch printed on the PCB. Next, we're doing the three-legged transistors. There are two types of transistors in this kit, 3904 and 3906, and you see me sorting and separating them. The 3904s are simply labeled 04 on the PCB, and the 3906s are labeled 06. Line the transistors up with the print on the PCB. There's a curved front and a straight back. I'm doing the 3904 transistors first. I'm staggering out the placement of them so that I don't have too many legs in the way when I solder. Transistors are sensitive to heat, so I like to solder one leg at a time, then go back and solder the second leg of each transistor, and then finally do a third pass soldering the last leg of each one. This way, there's a cooling off period and we're avoiding prolonged exposure to the heat of the soldering iron. Next up are the diodes. Just like the freestanding resistors, the diodes are going to stand up on end. The striped end of the diode must touch the marked hole here. Diodes are also heat sensitive, so we're going to solder one leg at a time for each diode. Now we're doing the 10-pin power header. I prefer power header pins that come in a single 2x5 configuration, but here we have two separate 5-pin headers that are placed in parallel to each other. I like to be extra cautious about placing power pin headers. I'm using the power cable to ensure that I have everything orientated correctly. Accidentally soldering the power pins to the wrong side of the board can be a costly mistake that ends up taking hours to fix. I'm soldering the two outside pins of each row so that I can make sure the pins align properly with the power cable. Now I'm plugging a disconnected power cable into the pins, and then I'm going to finish soldering the power pins with the cable attached. This guarantees everything lines up properly, but it's important not to use too much solder as you can fuse the power cable to the power pins. We want the power cable to be able to detach after the pins are soldered in place. I'm doing the last couple of pins closest to the diodes without the power cable plugged in. I want to be as careful as possible not to touch a heat-sensitive diode with my soldering iron. This is going to be the back. There's going to be a control board that goes here, and then the faceplate. Now we're doing the pin headers and shrouds that will connect the control PCB to the main PCB. I'm counting the pins to make sure I place the correct one. I start by doing the outside pins to hold everything in place. Then I check to make sure everything is straight and flush. Then I go back and solder the rest of the pins. According to the instructions, quote, "The hard part is over." Now we're setting aside the main PCB and pulling out the control PCB. We have those 6 10K resistors from earlier, and we'll be standing them on end. resistors standing on end make it so we can't lie the PCB down flat while we solder it. This is an instance where having a PCB holder would be a good idea, but be cautious. I bought a cheap one off Amazon. It was completely useless for holding a PCB in place. The pin headers to the control PCB so that it plugs into the shrouds in the main PCB. I decided the best way to do this was to actually plug the pins into the shroud and solder the pins to the control PCB that way. Like with the power pins, you must be cautious not to use too much solder as we don't want the pins being fused into the shrouds. Spacer and screw to the control board. This will keep the faceplate the proper distance away from the control PCB and all its components. Now we're placing the pots, LEDs, and jacks, but we are not soldering them yet. Is the faceplate. We're adding a screw that goes into the spacer and hand tightening the nuts for all of the jacks. The LEDs in their holes and solder those first so I can get their legs out of the way before soldering the jacks and pots. You'll notice I check each LED multiple times to make sure they haven't fallen out of their hole on the faceplate. With the LED legs out of the way, I begin soldering the jacks and potentiometers. Go back and place the ICs. I could have done this earlier, but I like to place the ICs last so they cannot be damaged. Make sure the markings on the ICs properly align with the notches in the sockets. It's important to pay attention to the markings on each IC as there may be more than one type of IC that can fit in each socket. Now we're combining the two boards. I almost forgot to test the continuity on the power pins. This is important to do before plugging it into a live power supply. We want to make sure there are no shorts in the power circuit. Now we're testing the module to make sure it works. I'm just plugging an oscillator into each input and making sure we get sound on the output. There is a calibration process that I did not record. It simply involves turning the volume pots down all the way, turning up your speakers, and adjusting each trimmer until you don't hear sound anymore. And now for some tunes. Thank you for watching my video on building the Zlob Modular VnIcursal VCA. If you watched all the way to the end, please consider liking and subscribing. Have a great day.